Hello, everyone. Welcome to another Partner Spotlight brought to you by WWT Present. My name is Earl Dodd. I'm part of WWT's business practice that lead the high performance computing supercomputing group. And I'm absolutely stoked to be here to have this conversation with two dear friends and two incredible people out there in the supercomputing industry. So today, please welcome and joining us is Uli, and Uli leads the HPE's worldwide partner marketing program. He's also leads the parallel HPC and AI and storage. So he's all things HPC, all things AI at HPE. And also welcome Gretchen. Gretchen, congratulations on your new role, your chief data scientist, and you basically help lead that activities in the Intel public sector. So again, thank you so much for being here with us. Today, it's exciting today. We just got past Exascale Day. If you didn't know, 10/18 Exascale Day. And we're going to be talking about the essential role of putting together HPC and how HPC together with AI is driving just an incredible advancement of science and business. And it's a topic that everybody's been talking about, right? I don't know of any conversation that hasn't happened about AI and looking at the growth and the initiatives around that. So we're going to be focusing on the essential roles of HPC and AI, but I want to kind of back this up because what's really exciting here and why we have this team of folks on this call is because they've been very integrally involved in the Aurora supercomputing computer. So the Aurora system at Argonne National Labs is the world's largest computational machine ever built. And it's exciting. So, it's at all extreme scales, 21,000 CPUs, over 63,000 GPUs, massively parallel system, converged HPC AI workloads in over 10,000 blades. This beautiful piece of machinery sits in 166 liquid-cooled cabinets. It's the Cray, HPE's Cray EX supercomputing system, connected with Slingshot. You may have heard of that before. And it's, as I said, it's specifically designed for this convergence, this confluence of HPC and AI workloads. Now,
Hey Earl, Earl, this is Uli. So can I make actually a quick comment, on what you just said?
yes,
That is the biggest computational machine ever built. So I joined the HPE family coming from Cray. And if you compare, the Aurora system with the Cray one, the first supercomputer, the Cray one, serial number one of the Cray one was installed 1976 at Los Alamos National Laboratory, as you well know. And if you compare the compute performance, that had 160 million operations per second, the Cray one, 160 million operations, megaflops. And if you compare that to the Aurora system and you would line up Cray ones side by side, the width was about 100 inches. Side by side, around the Earth, you would go 410 billion times around the Earth. It's stunning, what progress has happened, in the past. And that makes me super, confident about the future of humankind, actually. It's unbelievable, the problems we can solve.
Yes.
yeah, and so that's the whole thing. That what I want to get from you folks is it's great. This is the world's largest machine. It can do so much, but what we're going to dive into is how does this work for the enterprise people. How do we go at scale, both up, down, wide, and deep on that? One of the major drivers out there is this thing called AI, and uh, we say here at WWT, we talk about, hey, if you want smart HPC, you must use AI. If you want fast AI, you must use HPC. So, I'm sorry that I spent all this time kind of announcing or talking about Aurora, because it's super interesting to me. But uh, you know, what is the impact to mankind and humanity here? So I'm going to start with Uli and then go to Gretchen. What does something like Aurora do for mankind? Uli?
Yeah, so I can start, and there, there are some problems, in tackling the grand challenges of mankind, that even with the largest supercomputers, kind of a year or 2 years ago, couldn't be tackled. And a good example is full device simulation. So, and I give you two examples, and they're really interesting. So, one of the things is, you might have heard, and the audience might have heard about, fusion energy. So basically bringing the energy of the sun and the stars to Earth, and having a clean, endless energy source that produces, around the clock, not like wind and solar, no CO2 emissions, and unlike fission, nuclear fission, no risk of a chain reaction, no nuclear waste. It sounds too good to be true, But one of the things, and that technology works actually in experimental reactors. But the scientists at Princeton and at the brightest minds of the mankind around the Earth basically have been saying, so far we only could simulate a little piece of the device. It's basically a device. It's called a tokamak, and there's plasma in it built from deuterium and tritium, and your magnets holding the plasma, and the heating, and all this stuff. And because they only had the compute power to really simulate only a little piece of the device, so they felt that they really are held back in producing, a real fusion power plant.
Absolutely.
So and they think in 50 years, and that might pull it forward 20 years. And so it's this whole device simulation that now is possible, and around the world. So scientists, by the way, there's a project which is called ITER, the International Thermonuclear Experimental Reactor. It's currently built south of Marseille in southern France. And noteworthy enough, it's the whole EU, it's Switzerland, it's the UK, it's the US. No big surprises there, but also Russia is contributing, China is contributing, India is contributing, because that will change the trajectory of mankind if we have the energy of the stars in a controlled, safe way, on the planet. I mean, this is really just one example. And the other one was the human heart, when it beats with 1 beat per second, and you want to simulate every single fiber of the human heart, needs a machine like Aurora. Every single fiber. So it's totally crazy. What you also can do in medicine and so on. So and I'm shutting up now, Gretchen. Let you also a little.
Yeah. So
No, that's fine. I'm honestly going to be a little bit of a geek and go backwards and say, one of the real beauties of Aurora and what we're really able to do is alleviate all those bottlenecks. And there were challenges before, especially in high performance computing, where you did a lot of research, but you basically set up that schedule and you had to wait till you got the information back. And, you would then take that information and you'd write papers, or you'd change some of the work that you wanted to do. But this design, really leveraging asynchronous object storage, allows you to eliminate those kind of bottlenecks, which really means that confluence of HPC and AI is so able to happen because of all those data intensive workloads. So the stuff that you were talking about, Uli, talk about the data that's being pulled together to be able to figure that out is
Yes.
unbelievable. And when you then think about figuring out how to solve Alzheimer's, or looking at, my dad died of cancer, colon and liver cancer, and what that means, and the amount of data that you now can synthesize through that corpus of information that you can then use to be able to help solve some of the hardest problems on the planet. Climate change, as I said, things like Alzheimer's, cancer. I mean, there's just so many things. And as you were talking about taking the power from the sun, all of that now doesn't have the kind of bottlenecks it had before. And I want to lay this out in terms of, people know that Tesla, and I won't at all say anything good or bad about Tesla, but just want to say that they built, and they've gotten a lot of press lately on a supercomputer that had, I think it's 10,000 GPUs. And what we're talking about in this system is 60,000. And it's able to be done through high bandwidth memory. You mentioned the slingshot fabric. I mean, again, all of that integrated provides the capability to really solve the hardest problems on the planet and in the solar system. It's so exciting, and really something that I know we all could talk about for hours.
Yeah, Gretchen,
It's
so
so
one
amazing.
thing which I also find super exciting is, just think about that. So a car manufacturer, Tesla, announces that they're building a supercomputer,
Yes.
with 10,000 GPUs, and the market valuation goes up by $70 billion. 10 years ago, somebody would have announced a supercomputer. It would not even been a small article on page 8 of the local newspaper. And the reason for that is because supercomputing, nowadays, is really seen not just as, a tool to tackle the grand challenges of mankind and leaving our children a better planet and all those esoteric great things,
Mhm.
but it's actually, seen as a competitive weapon, a competitive differentiator. Being able to run
Absolutely.
large scale simulations and also, large AI models, and to embed that into your enterprise applications and into your enterprise business processes. But what made me really happy as somebody who's doing supercomputing since a long time, as I said, 10 years ago, nobody would have cared. Oh, there's a new supercomputer.
True.
How boring. Now market valuation of one car
Well,
manufacturer goes up 70 billion just by that news. It's crazy.
Yeah, it
well,
is. And you bring up a really good point, Uli, in terms of people never really thought about what high performance computing had done. I mean, crash dummy analysis, weather forecasting. I mean, there are so many things that we deal with on a daily basis that have been using HPC systems behind the scenes.
Yes.
And to your point, now people are like, oh my gosh, that's how we get things solved. Generative AI. I mean, everybody thinks that's the new oil or whatever you want to call it. It's the answer to everything, but it has to be run on a supercomputer. I mean,
Yes.
the number of the trillions and billions of parameters that you're talking about within some kind of Llama 2 model, or whether it be a chat GPT, et cetera, those need supercomputing systems. I mean,
That's
and
right.
it just the incredible thing about this for me personally is that now it makes people start to think about, well, how can we ensure sustainability? What do we need to think about responsibility in terms of the transparency of what we're doing? And it just opens up so many very interesting conversations that really have nothing to do with the supercomputer itself. It's just that now we have the capability to solve some of these really hard problems that then make you start to have the additional conversations about, what does that mean around humanity? What does that mean around security? What does that mean specifically to our daily lives as we're able to tackle some of these really incredible problems?
this is an exciting discussion. I think we can go on forever here. One of the things that popped in my head here is maybe not everybody knows what HPC is, or supercomputing, and we've been kind of alluding to it with scale, but it's also a very good, basically here with HPE and Intel, there was co-design that put into this. The most supercomputers today are built on commodity architectures, but they're at a certain scale and interconnected, tightly coupled, put together to perform work in one of two ways. There's the capability market, that where an Aurora, for example, could work on a single problem, like Uli mentioned in fusion, or a big Alzheimer's model of every neuron in the brain, and work on that one problem at one time. And then there's the capability of a supercomputer to be a capacity or throughput machine where you put many workflows on it. The other thing that distinguishes HPC from other enterprise workloads is this is not a virtualized environment. There's no concept of VMs on there. Although containerization is a big thing, and running that, especially in throughput environments. So just think of everything at scale, condensed, densified, compacted, and running some of the world's largest problems, or a lot of them simultaneously. And the other thing that has just dawned on me is one of the things that people don't realize about HPC and supercomputing is the effect of what I call the time machine. So you can go back in time, or you can go forward in time. So you can look at and analyze what has happened in the past. We've been doing some stuff on climate models and paleontology and things of looking at forest burns and things of that nature, all the way up to doing prediction. And so when I think of prediction and that kind of activity, I start thinking about AI. So Gretchen, if you were given this time machine, and you're sitting there, what does that look like going, based on the technology like Aurora? What does that time machine do for you? What does it do for others? What can you do with it?
Yeah, I think the first is that people need to realize that lots of times, from an artificial intelligence, machine learning, deeper learning perspective, that you're developing and building models on smaller systems, sometimes even your laptop. And then the thing that you're able to do with the supercomputer is you can now run rigorous tests. You can incorporate pen testing. You can think about, in the past, as an example, when you did pen testing, it might have just been a denial of service. So let's do that. Or it might have been some other components that relate to the security, but you do them all serially as opposed to together. And now with artificial intelligence, you can say, I want to run all those security tests on the models that I'm building or on the systems that we are looking at designing all at the same time. And this rigorous testing and training allows you to weight your models different, do a lot of tweaking. And when you've got a supercomputing system, this allows you to be able to do that at scale. So earlier you were talking about, smaller, being able to scale out or being able to scale up. And that's the real benefit, especially when you're thinking about artificial intelligence, because now you've got all that historical data, or you've got time series data, or you've got structured and unstructured data that you want to pull all together and be able to train your systems quickly, then do inference, then retrain, then add additional information, additional data that you might be capturing at the edge, or that you might have realized that somebody just did a study in Germany, that you want to take all of that data and incorporate it into the models that you're building. And so this allows you to be able to do it at such scale, in such speed, to get answers so much faster. It's, again, just, if you can't tell, it's really exciting. It's something that I have a lot of passion about.
Well,
just one comment.
Uli, I just want to make sure that people know we've used the word scaling quite a bit. And I want you to double down on that, because HPE, through their prowess, through the acquisition of SGI and Cray, solves that problem of scaling. So I want to make sure you include that in this discussion.
Yeah, I just want to comment quickly on something Gretchen said, which is also you can do things faster.
Absolutely.
And I think if you think about high performance computing, generally it doesn't matter whether you're talking about AI models or a workload like modeling and simulation. Typically, it's always about how can I complete one task, training a model, fine-tuning a model, whatever, in the shortest possible time.
Yes.
And I have a good anecdote here because, so a lot of the people probably are familiar with ChatGPT, so here, kind of the audience. And in Europe, the largest supercomputer in Europe is a lot smaller than Aurora, by the way, but still a powerful machine, but a lot smaller. And it's in Finland. And so Finnish professors from universities got together and said, we need to create a Finnish language model, large language model, like a ChatGPT in Finnish language, because nobody cared to do a Finnish language model. And then they did it. And then, we asked them, so what was the benefit of you being able to having access to Lumi, the largest supercomputer in Europe? And they said, it's very simple. If we would not have had access to Lumi, but just to our university resources in the university, we still would train the model in the year 2025. So, and you can compress, like you said, the time machine. You can compress things, by orders of magnitude, and that is super exciting, so.
Yeah, it
Just
is. And Uli, to add to that, the other real benefit of this is that a system like this allows you to have much more data. And so while you'll never reduce bias, the truth is if you're training your systems on something small that doesn't have all of that data, you're not getting a better diverse data set that then allows you to have something that's much more accurate. And so the idea is you may be training those, but then when you've got that kind of storage and memory all built into Aurora, that then allows you to be able to take such immense amounts of data and be able to do that, as you said, at scale, to be more accurate, to get that data and the results so much faster. But then it also really does allow you to then tailor what would be next, the what ifs. As Earl was saying, we go back and we look historically, but we want to do a lot of predicting. So now you're able to really very quickly pull in a whole bunch of other different points of view or points of data that allow you then to look at what if scenarios, the how do we predict something, what are the things that we need to think about. And again, part of the benefit of all of this is building that not only diverse data, but the truth is it's a team sport. This is not a single researcher or one person doing something. It is really a team sport. And I think that team sport is really illustrated by the fact that to get Aurora up and running was WWT, was HPE, and was Intel, us all working together just like you need to solve these really hard problems.
Thank you.
And if I can just comment something from my Cray history, what's really exciting is, so at Cray we always had awesome technologies, and built amazing supercomputers, much smaller than Aurora, but by then also the biggest, and in a lot in partnership with Intel, over the last 30, 40 years and so on. But what's now really super exciting being part of Uli Plechschmidt Enterprise is that, at Cray we never had the reach into enterprises, so who want to run, simulations, digital twins, AI and things like that. And, being part of Uli Plechschmidt Enterprise, enables us basically to package those technologies now in a way that are, consumable and digestible for enterprises, and even more importantly, work, with the channel partners of HPE, like WWT, so to be able to distribute those technologies, also, in the right way, to enterprises. And that was not the case before. We always built cool supercomputers in the last 30, 40 years, but it never really was able to be translated, into something that enterprises truly can use, because we didn't have the partners, actually like WWT, that can reach the enterprises. And, so we're super excited about that. So thanks for having me, by the way.
Yeah, no, Uli, you bring up a really good point, and I know we keep interrupting. I know Earl probably wants to talk about something else, but you bring up a really, really good point that a lot of people I don't think understand, that when we build high performance computing systems like Aurora, something really immense that, oh, by the way, most enterprises are not going to be able to buy. The thing about HPE and WWT and Intel is we take those learnings and then we build it back into our product. And so a lot of the cutting edge technology you're going to see in a next generation, the fourth generation or the fifth generation Xeon processor, or you will also see what we've learned from the interconnects and the high bandwidth memory that we adopt better Ethernet or better NIC cards for others that are putting together enterprise kind of environments. And so while it might not be the 70, million or multiple $billion system that somebody is able to set up, the value of what we do gets built back into the ecosystem. And, as an example, Uli, the Silicon as a Service that you all have in GreenLake, that capability really came from some of the work that we have been doing together at Aurora that provides those capabilities for somebody from an enterprise who doesn't have that. They can get into GreenLake, build what they need to build, create that Silicon as a Service for them to be able to then solve some of their competitive problems that they have with the data that they have. So
That's right.
it's really, the benefit is just tremendous in terms of not only does it help save some things in the world. I'm a huge environmentalist, and I really believe that a lot of this is going to help us save the planet. It also helps build better services for those in the government that I work with every day, and provides better services to the citizens,
Yeah,
and helps integrate the health and human services from a perspective in the federal government down to a VA hospital, et cetera, to have those capabilities be able to leverage throughout an environment.
I want to chime in here. There's a very important point here that you've alluded to, and we take it for granted in the world of HPC and supercomputing, but that is sustainability. Most people don't realize that the largest systems built on this planet by HPE with Intel and through our partnership are also the most sustainable. They produce the most amount of work per energy unit consumed. Most people think, well, gee whiz, I've got a 20 megawatt, 40 megawatt supercomputer. That's how we talk about, not necessarily the flops, the floating point operations per second, how I can do math, but also how much power do I suck in. But people don't realize, even though we get a force multiplier effect because of that density, because marshaling this, because of that scale to do things that can't be done, doing it faster, we're actually more efficient,
Yes.
have a better sustainability story than the enterprise class general purpose computing. And so part of the reason, you mentioned the car company and stock evaluations, we're seeing enterprise pick this up real fast right now, because then they go time to market, molecule to market.
Yes.
For our pharma people that we do this for.
Mm-hmm.
Higher confidence level, de-risking. Most people don't realize a supercomputer de-risks problems.
Yeah, and what's really exciting, Earl, there, I think this is the first time, the first year, in the history of the supercomputing industry, that analysts, specifically IDC in that case, are forecasting that enterprises will outspend the classic HPC labs on high performance computing technology.
Mm-hmm.
And the reason is exactly what you said, So from a simulation perspective, whether it's supply chain, new product development, and so on, in the digital transformation, and, integrating generative AI and enterprise applications and business processes and so on, that relies on supercomputing technology. And this is why, those supercomputing technologies that were very esoteric, like a niche thing, are now finding their way, into the enterprise mainstream market. And then the exciting thing, what we can do together, so WWT, HPE, Intel, we can say, hey, you can start small and then you can scale to wherever you need to go in the future. You don't know where you need to go, but it's peace of mind. You can scale until the doctor comes, because in the architecture. And then we give you the flexibility. You can run this thing on your own in your own data center, or we can manage it for you, or you can run it in a co-location facility, or WWT can manage it for you. So you can purchase it, you can finance it, you can subscribe to it. That makes it really, enterprise ready, I would say. So it's not that enterprises need to be afraid. Oh, it's this big Aurora thing, the big supercomputer, and yes, those labs every 5 years, Big Bang approach, and that's it then, and 5 years planning cycle. We are bringing those technologies basically in a format that enterprises really can consume, and take a business advantage and differentiation out of them.
Yeah.
I agree. And the truth is, no enterprise can afford to ignore the potential, the unprecedented potential of generative AI. I mean,
Right.
you talked about IDC, but Boston Consulting also says that the potential to disrupt every industry is here today. And
Yeah.
it's going to help from a competitive advantage, creative. I think
Destruction,
some of the words
creative
I've been
destruction.
using
Yeah.
is creative destruction, but I think it really enhances creativity
Yes.
because it allows you to ignore some of the kind of rote things that you've had to do for quite some time. And I think that WWT, HPE, and Intel are really well positioned to help any of our customers be able to understand how they can take advantage of that. And again, the high performance computing work that we've done is absolutely translating to how enterprises can take advantage of generative AI. And as an example,
Absolutely.
Intel even worked with Boston Consulting to help them internally. So we all know Boston Consulting, they are based on their intellectual property. It's their PowerPoint slides, it's their documentation, it's all the work that they've done over the last 50 some odd years. But for them to find that in the corpus of data that they have, to find information has been more and more disheartening for a lot of the people that work there. And so, learning what we have from high performance computing, we were able to work together, have a model that was built that they could apply to their own proprietary data, done in a double blind way so that we were not seeing any of their data. And literally, they were able to find something that they had been looking for, a particular, hey, I did this particular work for the auto industry. I know it had these 3, 4 points. It had a quad chart in it. Literally, people were working for weeks trying to find it. The person said to the chatbot, this is the industry. I wrote this probably this many years ago. Here are some of the key points. And he hit enter, and the information he was looking for came up.
Wow, this has been fun. We're running out of time. We could stay here for weeks. I know, but let's kind of close this out. So I'm going to start with you, Gretchen. What's your closing thoughts? What is that one or two things that you want people to leave with?
And thank you so much. This has been an awesome conversation. I'm going to put on my sales hat, which I'm not usually very good at sales. I tend to be an engineer at heart, which is the call to action. I think between WWT and HPE and Intel, that we just need to leverage the Advanced Technology Center that's part of what WWT has, and that we really can help solve these problems. And I would say, call us and we can do a workshop and we can help you figure out the best way to leverage this kind of capability rather than the spray everywhere and pray it sticks. Let's look at something specific and we can really get that ready for production.
Thanks, Gretchen. How about you, Uli? What's that one or two key knowledge chunks that you want to leave?
Yeah,
For
so from a knowledge chunk perspective, I would basically say that no enterprise can ignore the transformative potential of generative AI. And generative AI relies on supercomputing technologies and really scale, like we discussed. And some customers, when they're looking at this, they will say like, hey, why just not go to the public cloud? Proof of concepts, small proof of concepts with AI. had made some decent experiences with running and developing, training, fine-tuning our small models, in the public cloud. And the reason why I advise against going full production, fine-tuning large models, and AI models and inferencing, serving those large AI models, is that it's not just architecturally challenging, it's also economically very challenging. And so we talked about a couple of analysts like IDC and consultants like Boston Consulting Group, and there's Hyperion research that specifically is focused on the high performance computing and AI enabled, HPC enabled AI market. And their CEO said, after studying a lot of different projects, that if you run large scale AI models or large scale simulations, in the public cloud, so basically jobs that run 24/7, like serving AI, that can be 4 to 5 times more expensive if you do it on premise, either in your own data center or in a co-location facility. And so we can help you, WWT, Hewlett Packard Enterprise, and Intel, to basically architect something for you that serves your business need, differentiates you, but doesn't break the bank. So it's also, I think, important, price performance.
Excellent. Thanks, Uli. Yeah, my closing thought there is smart HPC demands AI. Fast AI demands HPC. So again, I want to thank you both. I really appreciate it. It's a great partnership that we have with HPE and Intel. I also want to thank our viewers and listeners for this. We think it's a fascinating topic. We hope you feel that way. Please go out to our platform, wwt.com. Go to the HPE and Intel websites. We have partner pages. We have lots of information there. We have also our labs and capabilities, as Gretchen mentioned, at the Advanced Technology Center, at the ATC. There's a wealth of resources there. If you didn't find what you need, ask ChatGPT. No, just call me and we'll get together. So please, free to send us information, send us feedback. I really, again, appreciate this. We look forward to having you attend the next partner spotlight that's been brought to you by WWT Presents.
Thank you. Thanks for having us.
Thank you so much.
You're welcome.
Excited to have this conversation.